The next topic that we have is momentum. Do we have any idea about momentum? Yeah, so momentum is mass in motion or the motion of a mass. So it depends on the mass of the object and the velocity it's moving at. We cannot say that it's the speed because momentum is a vector quantity and we need to include the speed as a vector quantity and that would become the velocity. So a few things before moving ahead. It's your duty, it's your job as a student to identify which one is a positive direction or which one is a positive momentum and which one is negative momentum. It's your choice, you can choose any one of the two. For example, if the object is moving towards the right side or upwards, these directions of velocities and consequently momentum will be taken as positive directions. Similarly, if we had an object that is moving towards the left and is moving downwards or is moving any one of the two, right? So they will be considered as negative. Momentum does not become negative. Eventually it does, but it's not that momentum is becoming negative. Actually, the velocity of the object is becoming negative or positive. Mass has no direction, so it's a scalar vector. It's a scalar quantity. So why do we need to say this? Why do we need to understand this? Then this is how we actually. Now, for example, if I say that an object of mass 5 kgs is moving towards the right with a speed of 10 meters per second, then what would be its momentum? How to find the momentum? That would be 5 multiplied by 10, which would be 50. Now, the unit of momentum is Newton seconds or kg meter per second. You can write any one of the two. Both are acceptable. How do we make kg meters per second? Because the unit of mass is kg and velocity is meter per second. We just combine them together because both are being multiplied. Right? Okay. So this is how we find momentum. Then we have a few cases that how to find the momentum of a system before and after the collision. There are two types of systems in physics. The first one is elastic collision system and the second one is inelastic collision system. So what is the elastic system and what is the inelastic? So in elastic system, the momentum is conserved kinetic energy is also conserved. But if you move to inelastic, momentum is conserved, still conserved, but kinetic energy is not. And usually, not every time, but usually, these will be the systems, the inelastic ones, in which the object or objects after the collision do not separate. For example, a bullet fired in a wooden block, the bullet would embed itself in the wooden block. So in that case, most likely that would be an inelastic case. And in systems where the objects do not embed themselves or do not combine together after the collision, they're generally known as elastic systems. But these are just reference examples from the daily life examples and from many questions that I've solved over the years. This is what I've found. But sometimes if this test fails, then it's your job as a student to always verify before giving this conclusion, whether it's elastic or inelastic, to find their kinetic energies. And it's very simple to do so. Why? Because kinetic energy is half mv square, mass and velocity square. So for the momentum, you need mass and velocity. So if you already have both of these quantities, then calculating the kinetic energy will not be a problem for that certain scenario. So in elastic, what happens is that two objects may be moving towards each other, they separate from each other, or they may end up moving towards the same direction, but they will not be in contact anymore. In inelastic, this is just a generic case. It's not going to happen every time. It's your job. If you have to give the verdict, you have to give the verdict based on elastic and inelastic. Okay, so over here, it's possible that both objects are moving towards each other. They both join together and start moving towards the right side, or both join together and start moving towards the left side. This is a general case. If I have to verify this, then I'll have to find out the kinetic energies and then give my verdict. Do we understand momentum and collisions? Yes, do we understand momentums and collisions? Alright, let's try to solve a question. He tells us that there are two objects moving towards each other. He says that this is, let's say, 1 kg moving at 2 meters per second. This is moving at 3 meters per second, and this is 2 kg. He's asking you, or you can say he's telling you, that they both embed in each other. They both join together and now continue to move in a certain direction, but we don't know what that direction may be. But we can predict what that direction may be. How can we do that? Out of the two systems, whichever has the higher momentum will be dominating the system. Okay, so I wanted to find out the momentum of this one as mass velocity, that would be 2 Newton seconds. And for this one, that would be mass into velocity, that would be 3 into 5, 3 into 2, that will become 6 Newton seconds. So I know that the momentum of left side is greater than the momentum of the right side. So it's my prediction that the objects will be moving towards this side after the collision when they have joined together. Now, how do I find this? For that, I will need the conservation of momentum principle, or you can say principle of conservation of momentum, that says that momentum before and after collision is same, or you can say the better word is conserved. So whatever momentum it had before the collision, it will have the same amount of momentum after the collision. So let's try to figure out the total momentum before the collision. So before the collision, this is my whole system, and after the collision, this is my whole system. Okay, so I realize that before the collision, that would be 1 multiplied by 2 plus, now if I go back, we remember that we have to assign values to velocity based on left or right, upwards or downwards. So I see this is positive velocity, but this will be negative velocity, plus, because I want to find the total momentum, so I'll be adding them together. So this is going to become 2 kg multiplied by negative 3 meters per second. This is all before the collision, must be equal to after the collision. But after the collision, I see that if I want to find mass into velocity, velocity is what I don't know. I know the mass. How do I know that? Because this was 1 kg, this was 2 kg, and now they have combined together, so the total mass would become 3 kg. Do we understand this point? But velocity is what we don't know yet. And since we have taken care of the negative sign, our final answer will also be correct. So this becomes 3 minus 6 equals to 3v. This becomes negative 3 equals to 3v. V becomes negative 1 meters per second. The negative direction suggests that it should be moving in this direction with a speed of 1 meters per second. Why the negative sign is leftwards? Because in my question, I chose it to be that way. Do we understand this question? Any problems? Alright. The same question he can give you with a different context. He may tell you that there is a wooden block, for example, and somebody fires a gun, and the bullet actually embeds itself in the wooden block, and then it starts to move. In that case, even, you'll have to add the mass of the bullet and the block in the after case, because now they're embedded together. right? So just keep an eye out of these cases. Sometimes what he's going to do, he's going to give you the cases like this, that both were moving towards each other, and after the collision they are moving towards this side. So he will give you all the data. Let's say this is 5 meter per second. I'm taking arbitrary value. This is 2 kg. This is 1 kg. And this is, let's say, 2 meter per second. He gives you all the values. Then after the collision, he will also give you the values of one of the cases and ask you for the second one. Let's say he gives you the credentials of this one, that this is 2 kg and it is moving at 2 meter per second. This is 1 kg ball. How much or what is the speed of this object in this case? So what you're going to do, this is my before case and this is my after case, right? So before case would be 2 into 5 plus 2 into minus 1 minus 2, that would be, not minus 1. Negative 2 because it's moving in the left direction, and 1 kg will be the mass, equals to, now since I have the data of one system, I will write it as this one. So I have considered all the rightward direction to be positive. So this becomes 2 into 2 plus 1 into V. Now I know that this is going to be positive because the examiner has given me the direction himself. I don't have to figure that out on my own. So what does that become? This becomes 10 minus 2 equals to 4 plus V. This becomes 8 minus 4 equals to V, and V becomes 4 meters per second. Positive value, meaning this is moving towards this direction. So do we understand how to find out the momentum before and after collisions? Yes, are we clear about this? We've tried to explain the laws of Newton with simple force. Now we will explain them with reference to momentum. So if I just give you a simple peek about the first law was about inertia. That as long as there is no external force, the object will maintain its state of motion. Now we will say that as long as there is no external force, the momentum of the object will remain the same. And the second Newton's law we will call force as not mass into acceleration, rather change in momentum, or the rate of change in momentum. We will get to all of these topics later. We don't have to worry about this right now. This will be our next topic. And the third one would be, again, that as much as the momentum of the body A changes, the same momentum of the body A will also change. So it's action and reaction being opposite to each other. So in the next class, we will try to explain laws of Newton in terms of momentum. This topic was added in O-level syllabus because of precisely one reason, because this will be tested, or this will come in A-levels extensively. So since students didn't have any idea in O-levels when they used to do A-levels, they would just freak out because of this topic. So now they've introduced this topic at this level so that gradually you get used to this idea. You have all the basic introduction and information. So then in A-levels, it will become easy to understand this. Okay, so one situation more. For example, if this is a wall and I throw a tennis ball towards the wall and it bounces back. And if I want to find the change in momentum, that would be final momentum minus initial momentum, right? That is how we find the change. So if this is the mass of the object and this is the velocity, and I say that the velocity has not changed, it bounces back with the same velocity. So I'll have to add a negative sign because it's moving towards the left side in this case. And mass remains the same because it's a tennis ball. So my final momentum is negative V multiplied by mass, negative because of the formula, and initial momentum is positive mass multiplied by positive velocity. So what I get is negative Vm minus Vm. So that becomes negative 2 Vm. Do we understand this? This is what's happening in gas pressure. If you remember, we explained that a gas molecule collides with the wall and bounces back, and it exerts a force on the walls. This is how it's actually exerting a force on the wall. And we will do this in the next lesson, that how change in momentum becomes force. Do we understand this point? Yes? All right. That is all for today. If you have any questions from today's lesson, you can ask freely. Otherwise, I'll be ending the class.